Hi everybody, welcome to another video in Math 1332 section 2.4. This section is continuation from what we have on the previous section about Venn diagram, but this time we have three sets. Well, it's not much different. The operation that we do in which set, the intersection, the union, or the difference, we still do the same between two sets, and then we combine that with the third set. Right? So, order operation is inside the parentheses we do first, and then if not there's a complement, do the complement first, and then intersection or union from left to right if there's more than one. Right? Once again, inside parentheses, I better write that down. First will be inside parentheses. Next, if there's any complement, do complement first. And then intersection and union. So that is order operation. Right. Now here we have this example. Now let's do inside parentheses first. So we will do A intersect B. A intersect B meaning the overlapping of A and B. So what A and B have in common? So we have Chicago and Dallas. Right? So that is A intersects with B. Now C is this. Seattle, LA, and San Diego. Right? Now, we find the union of this. Union of this, of course, is either in A, in this set, or in this set, or in both. So we have A intersect with B, and then union with C is going to be in A, Chicago, Dallas, or in C, LA, and San Diego. Yeah, so that's the first one. So we just do the operation of two sets and then combine with what's left. Next, intersect of A and B, and then C. When we see something like that, just go from left to right. So we already have A and B, right? So let's write that again. A and B, or A intersect B, is Chicago and Dallas. Of course, we can draw the Venn diagram for this too, but I said we can just do math. And then C is Seattle, LA, and San Diego. Now we find the intersection of these two, and you see there's nothing in common. So we say A intersect B intersect C. It's just an empty set because there's nothing in common. Right. Next, A union would be intersect with C, so we have to do inside parentheses first. What's B and C have in common? Right, we have LA, and that's it. And then A Indianapolis, Chicago, and Dallas. Now we want the union. The union may be either that or in that, or maybe both. So we say A union with B intersect C is in the first one or in the second one. Right, so that's what we have. Right, I said even though we have 3 sets, but the operation we just do for F2 set, and then inside in this order, and then we combine with the third set later. So no big deal, nothing new here. Right, the next one is a little more difficult. When we look at this, we have to be able to decide what is actually for that shaded region here. So when we see here, it's going to be in B, but not in A or C. So there are a couple of ways to do this. We know it's going to be in B, right? So I have to be start with B. But it cannot be in A. It cannot be in C. Or cannot be in the union of A and C. So we say B, but not in the union of A or C. Yeah, that's one way to do that. Another way we can say it has to be B and then outside of A and C. If we have A union C complement, if it is outside of that, and then intersect with B, would be just fine. So either one of those two things. Right, next, this we see that it is not in B, so have to something subtract B. That makes sense. But the part that subtract from it is, this is the overlap. If we're talking about A intersect C, sorry about that terribly. So that is A intersect with C, but it cannot be in B. So yeah, pretty much that. Or we can say A intersect C, but have to be intersect with the part that is outside of B. Yeah, so either way, describe the correct shaded region for the Venn diagram. Right, De Morgan's law. Right, this is not actually part of the De Morgan's law, but it just tells us how to do the math here. Usually, if we want to prove that the two sets are equivalent, we'll draw the diagram, use Roman numeral to denote the region, and then find the math for those regions, and then say the area corresponding to the set of numerical found in step 3. Right, so we're going to use this here to prove that they are equal. So we're going to we do for both sides. This is on the left side, this is for the right hand side. Right, now draw the Venn diagram for both. Okay, we did that. Now use the Roman numeral list on the region described by each set. Right, on the region. Right, so let's just denote it like this. On the outside of U, that is 1. Here's 2, 3, and 4. 1, 2, 3, and 4. So we list all the possible regions like that. Now find the set of numerical numerals that corresponding to set, and then for in the statement. So first, the left hand side here, it is A intersect with B and then complement. Intersect of A and B will be the 3, right? Intersect of A and B will be the 3, but the complement meaning outside of that, so it have to be 1, 2, and 4. And then say the region that have 1, 2, and 4. So 1, 2, and 4. Pretty much outside the 2. Right, so that is the left hand side. Now, the right hand side will have to do the same thing. So first of all, it is not in A. So we're talking about outside of 1 and 4. So we can just do that too. A complement is not in A, meaning 1 and 4. B complement not in B, meaning 1 and 2. And then A complement union B complement is 1, 2, and 4. So A complement outside of A will be 1 and 4. Complement of B outside of B 1 and 2, and then union meaning either in A prime, B prime, on both. So that's what we have. And then of course we say the same region. 1, 2, and 4, not 3. Yeah, so they are the same. Right. Next, decide if these two sets are equal using Venn diagram. Now, this is a little more complicated. We have 3 sets, but we still draw the Venn diagram for both. Right, let's do this. A, B, okay, 3 sets like that. Set A, B, and C. Right, now designate the region. Outside will be A, 1, 2, 3, 4, 5, 6, 7, 8. Right. 1, 2, 3, 4, 5, 6, 7, and 8. Right. So we draw a Venn diagram using Roman numeral. Now, left hand side. So for this, we do the inside the parentheses first. What is A union B? A union B will be 2, 3, 4, 5, 6, and 7. So that is A union with B, and then complement with C. So for this and C, what do they have in common? So as you see, I just want to draw C is 5, 6, 7, and 8. So what they have in common of these two is not 2, not 3, not 4. You see 5, 6, and 7. So we're going to mark the 5, 6, and 7. Right, so that is one side. Now we'll do the other side. Right. So first, A intersect with C. What A and C have in common? That would be just 5 and 6, right? Now what B and C have in common? Intersect B and C. Do inside parentheses first, and inside parentheses. B and C have in common will be just 6 and 7. And now the union of this. So union meaning in either that or this or both. So say A intersect with C, B intersect with C will be in that or in this or both. So it's going to be 5, 6, and 7 again. It's be 5, 6, and 7. Yeah, of course they are the same. So decide if they are equal, and the answer to that is yes, they are equal. Yeah, so just do it like that. And I said when we have 3 sets, operations still the same. We just do for every 2 sets, intersection, union, or difference. Of course, if complement, it's just for 1 set, and then we do pairwise operation of every 2, and then do this first, and then at the end for the union. Right. So pretty much that. What we have next is the De Morgan's law. It said the complement of A union B is intersection of the complement. So complement of the union is the intersection of the complements, and then intersection of the complement is the union of the complements. Right? Bit catchy there. Let me write this. Complement of union is intersection of complements. And then complement of intersection is union of complements. Yeah, I said a bit catchy there. just have that. Let's go to De Morgan's law. Right. Let's look at this example and then we might utilize that De Morgan's law. So we have this. So we have a universal set, those TV network. First, find the complement of A intersect to B. Now that we see the intersection, the complement, the union, and the difference, actually the easiest one to find is the intersection, right? The intersection is the overlapping. So when we see two sets, what overlapping, that is the intersection. So intersection in the sense is the easiest one to do. So in that case, we don't have to use De Morgan's law. We just go ahead and say, well, that's just the intersection of A and B. So we look for what A and B have in common. All right. I see the NBC. I'm looking at the common. And the Fox. So I just underline NBC and Fox. The others are not the same. So this is the intersection of A and B. I said intersection is the easy one to find. Next, the complement of that. Complement is also easy. Complement is not in this set, but in the universal set. So just list from everything in the universal set, ABC. Well, we do have NBC in here, so we're not going to count NBC. CBS, Fox already there, so we're not going to count that because it is complement. USA, TBS, TNT, and MTV. Yeah, so we just that. Operational, just one step at a time. In the parentheses first, and then complement, and then union intersection. Right. For this, there's two ways to do that. I'm just going to do first direct way. Direct method, A complement. So what is A complement? It's not in A. So we just list everything in U, but not in A. There's ABC, right? NBC already have, so we're not going to count that. CBS, Fox already have, not counting that. And then USA already have, not counting that. So it's TBS. So just TNT and MTV. So that is complement of A. ABC, CBS, TNT, and MTV. Right, not in A. Now, then we have B. ABC, NBC, CBS, and Fox. And after that, we just write what is A complement union would be. So in that case, it is in A complement or in B on both. So I'm just going to write what in A or in B. ABC already have, and NBC. CBS already have. Don't have Fox. Yeah, so just straightforward like that. Now there's another way to do this. Utilize the De Morgan's law. So let me write this a little different here. Or we can use alternative methods. So we start with again A complement union would be. There's no complement here. Now, remember I can do like this. Complement of complement. Right. Now, De Morgan's law, we can factor out the complement and turn that upside down. So, they should be equal. I'm just going to do this now. Right, A is that. I'm just going to write what is A, NBC, Fox, USA, and TBS. So that is A. Now not B. Not B is going to be not in this list. Don't have ABC, CBS, and Fox. Pretty much the remaining 4 here. Yeah. So this is the complement of B. Now we do the intersection. So what do they have in common? What they have in common is USA and TBS. And finally, we do one more complement of this. Sorry. Complement of that. So pretty much everything in U except for the USA and TBS. Yeah, except USA and TBS, because that's complement. So that would be ABC, NBC, CBS, Fox, TNT, and MTV. If we compare these two, they should be the same. Right. So, of course, we can utilize the Morgan's law, but like I said, we can just do it directly. So, this section, whether we have 3 sets or higher, the operation only be done between 2 sets. Intersection, union, or difference. The complement is kind of 2 sets as well. The universal set and not in that particular set. So we do 1 step at a time and then go to a new operation like we do inside first and then the complement. On this case, we find the intersection and then the complement or the operation. Each operation can be done between 2 sets. And then we go to the next operation. So that's what we have in this section. And with that, we finish section 2.4. Thank you for watching. See you in another video in Math 1332.